So for this question, it's pretty simple. Once I'm done solving, I'll post this as a PDF, the description. Right. So this is just pretty simple. What we have here is just V is equal to IR. All right. Just replace those. 30. This is, we got I. This is R, which is 5 times 10 to the power of 3. Giving us the value of I, which is how much? It's going to become 6 times 10 to the power of 3, negative 3 ampere, which you could also say as 6 milliamperes. Both are accepted. Right. So for the other one, we could do is that G is equal to 1 over R. 1. How much is R? R has the value of 5 times 10 to the power of 3, since it's in kilos. Replacing it gives us the value of 2 times 10 to the power of negative 4 seconds, which you could also say as 0.2 milliseconds. Both are accepted. All right. For the power, in order to find it, P equals to VI. How much is the voltage? Okay, 30. I know the current. We found the current previously, which is in 6 times 10 to the power of negative 3. Negative 3, since it's in milli, which gives us the value of 0.18 watts. All right. For the next question, what we could do is that we're going to apply KCL. So what's KCL? It's Kirchhoff's current law. So what we want here is that we want to know what's going inside, what's going into this node, and what's going out of this node. That's our main goal. So what we'll do here is that we're going to apply that in is equal to out. So the current in is equal to the current out. So what's going into node 1? What's going into node 1 is 5 amperes. So let's just write that down. 5 is equal to, okay, what's going out of node 1? We got IC is going out. We got the 6 amperes. Solving for it, just basic arithmetic. So IC plus 6 gives us the value of IC, negative 1 ampere. So the value is negative 1. All right. So for this one, what we'll be doing, so let's just do this step by step. Usually we start with the one with the least amount of unknowns. So we're going to choose node 1. All right. So let's just choose node 1. So what we'll be doing here is that we're going to apply in the same rule, apply KCL. Right. For node 1, node number 1, we know that the current in is equal to the current out. All right. What's going into the node 1? What's going into it? We have nothing. Therefore, it's going to become 0. So 0 is equal to the node out. So what's going out? We got the 12. We got this. So that's going to become 12 plus the current IB. Solve for it. Give us that the IB is equal to how much? Negative 12 amperes. All right. So what about node number 2? In order to find it, we'll just apply that in is equal to the current out. All right. So what's, let me put it here. All right. So what's going in? So let's just look at node number 2. I know that for node number 2, I know that IB is going inside. I know it's IC is going out. I know that ID is going out. Yeah, that's it. All right. So we'll just write the equation now. All right. IB is equal to negative, wait, yeah. So let's just find node number 2, then we'll go to node number 3. Let's find 3, then we'll go back to 2. I'll explain node number 3. So for node number 3, there's an unknown that we have to find node number 3, so we could find node number 2. That's why. So for node number 3, what's going in, what's going out? I know that the 2 amperes are going in. The ID is going in. All right. What else? I know that yeah. So the 3 amperes is also going in. So let's just write down an equation to find that. So I know that the in is equal to out. So I know that ID plus 2 plus 3 is equal to 0. Therefore, ID gives us the value of -5. All right, so for this one, node number 2, we're going to say that, yeah. This is just pretty easy. What we'll do is that it's going to become no wait, sorry. So yeah, in is equal to out. All right. So we'll get the equation we need, right? So after rearranging the equation, we get the equation of IC is equal to negative IB minus yeah, ID. Putting that inside, get 12 minus 5 negative 7 amperes. Like that, you're done. All right, for this question, what we'll be doing, yeah, how many questions left? 3 questions, right? So for this question, what we'll be doing is that we're going to apply KCL. Apply KCL. So we know that in is equal to out. I know that 0. What's going inside? 0.5. Yeah, 0.5. I node plus 3 is equal to I node. All right, we're applying KCL at this point. All right, so giving us a value of I is equal to 6 amperes. All right, so if you want to find the voltage, V, we could call it, okay, so V amperes could be I amperes, R. All right, there's only one resistance, so just replace that, giving us the value of 6. This is 4. This is going to become 24 volts. All right. All right. For this question, we'll just be applying the loop law. So we'll apply, yeah. So for this question, we're going to, there's like this, our sign convention here is that there's a loop here. I'm just gonna call this loop. Yeah, there's only one loop. We have a loop here that's happening. All right, so how it works, let's recall s- how the rules work. So recall. Um, so if the charge is flowing from positive to negative, if it's from positive to negative, it's going to become, give me a second, it's going to become minus. Now, if the yeah, so if the current like the yeah, so if the current is flowing from negative to positive, therefore it's going to become positive. All right. So how is this flowing? We're going from, so let's just write a equation for this. All right. So we got loop number one. I know that 20, okay, how is it flowing? So it's flowing from positive to, sorry, negative to positive. All right. Flowing like this. So negative to positive. So that's going to become 20. So then it turns from positive to negative. So that's going to become negative V1. Then it flows again from positive to negative, which is going to give us, um, yeah. So it's going to give us minus V2 is equal to 0. Replacing these, 20 minus 2i minus 3i. By the way, just to show you how we got this, I'll show you here how we got these values from 2i and 3i. What we did is that we said that v1 is equal to ir 1 1. So replacing these, I 2 gives you 2i. All right, v2, this is I, this is r. Replacing that I, which is the thing we're trying to find, I, we'll find the I then, so we could find the voltages. This is 2, and this is 3 amp, yeah, 3 ohms, which is going to give us the value of 3i. Okay, once you're done with that, we will just find this simple equation. So this gives us the amount of, this gives us the current, which is equal to 4 amperes. All right. So once we're done with that, now we can find the voltage. So V1 is equal to IR. V2 is equal to IR. So let's just replace these real quick. So that's going to become, yeah, 4 and the R, which is how much? 2, which is going to give us the value of 8 volts. For I, with, it's basically 4 amperes. Got R, which is how much? It's 3, and that's going to give us the value of 12 volts. Like that, you're done. All right. So this is our final question. To find this, what we're going to do, this is slightly more complex. So we have two loops. So we can just categorize that. You can call whatever you want. So this is loop number one. We loop number two. This is the second engine. So for this one, we'll find each loop so we can find the voltages similar to what we did previously. All right. For this one, what we're going to do is that we'll apply KCL. So let's just apply that. Apply KVL, sorry, KVL, Kirchhoff's voltage law. All right. So this is going to give us the, so no, we're supposed to apply KCL, then KVL. So KCL. So this is going to give us V1 is equal to how much? 8I. V2 is how much? 3I. This is one. This is the second current. V3 is going to give us how much? 6I3. Okay. Once you're done with that, now we can apply KVL. So apply KVL. So let's just apply KVL real quick. This is for loop number one. So we know that 30 minus V1 minus V2 is equal to 0. We're applying the same rules that we did previously. So wait, sorry. So from negative to positive, so that's going to become positive 30 volts. Positive to negative, that's going to come, so positive to negative, that's going to become negative V1, positive to negative, negative V2. So that's going to give us 30. We're just applying the same rule, what we applied here. Same idea. So that's going to give us 30 minus 8I minus 3I square, I2, sorry, equals to 0. All right. So what we'll do here is that we're going to take these values and just apply it. Right? So n is equal to out. I forgot to write that. So I1 is equal to I2 plus I3. All right. So what we'll do here is that we're going to try to find the value of I1. We'll create an equation for I1 and input it to this, find for I3. Input it to this, and we'll find I2. All right. So finding for that, it's going to give us the value of 30 minus 3I2 over 8 is equal to 8, 1, sorry. What we did here is that we just put it the other side. That's the idea. 8 is cancelled. So then we get the value of those two. I1 30 minus 3I2 over 8. All right. So we found the value of I1. Now we're trying to find the value of I3. Just solve for I2, and then we'll get the others. I promise it's going to make more sense as we continue. All right. for loop 2, what we are going to do is that applying the same rule here. So, right. So V2, so positive, negative to positive. So positive V2, and for the other one, for the other loop, positive to negative. So negative V3. Just need to make that clear. Minus V3 is equal to 0. And V2 is equal to V3 on the other side. We just place those values. So 3i is equal to 6i. Yeah, 2. This is going to become I3. 6. These get cancelled. So now we end up with I3 is equal to I2, 2. All right, so we'll just replace those equations into this equation. We'll find I2, the value of I2. So let's do that. I1 is how much? 30 minus 3i2 is 8. I2 is how much? That's just I2. For I3, it's going to become I2 over 2. Finding that, we'll get the value of I2, which is how much? 2 amperes. All right. Now we can find the values of the other ones. So 30 minus, yeah, so I1, that's an ugly I1. I1 is equal to 30 minus 3. It's going to become 2, and that's an 8, which will give us the value of 3 amperes. All right, so we got our previous value. So yeah, I2 over 2 is equal to I3. We'll just place that. I2, once we replace it with 2, is going to give us the value of 1 ampere. 1 ampere, that's how we found I3. Now we can finally find it. So now we can do our final step. So V1, V2, okay, V1 is equal to how much? I1, R1, I2, R2, V3, I3, R3, equals to. So that's going to become 3 multiplied by how much? Multiplied by 8. It's going to give us the value of 24 volts. And this is going to give us, so 2 multiplied by 3, going to give us 6 volts. I3, so what we said previously, 1 ampere multiplied by 6 volts. How much? 6 volts. Like that, you're done with all the practice questions.